as we look at theories of combustion, the earliest forms we thought only had 3 elements necessary in order to have fire. Again, fire is rapid oxidation with the evolution of heat and light. This has now been overcome or replaced with a new theory, the fire tetrahedron, what we'll look at here later. But in the earliest days, we used to think that only 3 elements were necessary to have combustion. You had to have a fuel source, again, something that can burn, and basically you can pretty much make everything burn if you get it into the right state and at the right temperature. Heat, you have to bring a heat source in order to get that fuel source at or above its ignition temperature, and you have to have oxygen present. And that's no problem because the air we breathe has roughly 20.5 to 21% oxygen, and that is sufficient in order to support combustion. And then this was the earlier theory about, again, how fire and the elements that were necessary, but you will see today it's been replaced with what we call the fire tetrahedron because we found out another element needs to be present in order to sustain combustion. In the fire protection industry, we want to understand the concept of fire and the theories of combustion and how that relates to the different detection and fire suppression equipment that we would install. And if we look at the fire tetrahedron, there are 4 things that must be present in order to have combustion. And fire, by the way, is defined as rapid oxidation with the evolution of heat and light. And the 4 items that are necessary are fuel. You must have a fuel source, something that will burn. And I always tell students in the fire protection industry that virtually almost everything will burn. I could take steel wool, for example, and under the right conditions, put it on a battery and show you how it would combust. You must have oxygen, and luckily the air we breathe has roughly 20.5 to 21% oxygen content in it. You must have heat. You have to bring heat to the equation in order to bring an item, a fuel source, up to its ignition temperature so that it can burn or combust. And the last element is what we call an uninhibited chemical chain reaction. And that is a complex chemical reaction that ongoes as these items are present to allow combustion to continue. Why is this important? Because as we look at the fire protection industry, let's first look at detection. We know that fires, because of the elements of combustion that are released, we have said we already have heat, we have light in terms of light energy and flames, we have smokes or product of combustion, and so that relates directly to, say, fire alarm and detection. We build sensors that look for those products of combustion. And that's the theory behind early detection. If we look at the fire suppression things, what we know about the fire tetrahedron is that if we take one of the elements and remove it from the equation, we can put the fire out. Many agents actually use a combinations of methods to extinguish a fire. So if we were, for example, to take the fuel source and we remove the fuel source, just take it out of the fire would cease to continue to burn. Likewise, if we take oxygen and we reduce the oxygen level generally below around 15% from that 21% that we start with, we can cause the fire to go out. A good example would be a CO2 system, for example, total flooding, where we would flood a room with a concentration of CO2, usually depending on the hazard around 35%, reduce the oxygen level in that room, the fire would no longer continue to burn. Or by the use of water, for example, sprinklers, when we inject water into a fire scene, we cause the conversion of that water generally to steam, which removes the heat and cools things down below the ignition temperature so that we can no longer support combustion. So those relative 4 items are everyday, real-life, practical things that relate to what we do here in the fire protection industry.